So most of this chapter, it's all on, this whole chapter is on linear functions and like lines. So everything we do is in the shape of a straight line right now, right? So the basic idea of what we're going to be doing for the next few days is, right now, if I said graph this, if I said draw this graph, what is really the only method we have to draw that graph? But how do we do it? Like, how do I actually get to be able to draw the line that is actually represented by that equation? You have to plot a bunch of points, right? The only method we have right now is to plot points. And generally speaking, what points do we like to plug in? -2, right? Now, anybody enjoy that method? It's not hard, but what's the problem with that method? It's long, it's tedious, right? I want faster ways. So what we're going to now do is say, all right, we have that method in our back pocket. We can always use that method if we want to, but I want to come up with some other maybe easier and faster methods. One method is to use the intercepts. Okay? What do you think I mean by the intercepts? There's two of them. There's an x-intercept and there's a y. Oh, why are you doing that? I think it's my watch. Stop it. Huh? I don't know. So when I say x-intercept, y-intercept, what does that mean? What do you think? I wrote x-intercept, didn't I? What do you think I mean by x-intercept and y-intercept? If I draw any line, let's say I plot a bunch of points and the line goes like that. Where are the x and the y-intercept? Right. If I can find the x-intercept, this would be the y-intercept, right? And this would be the x-intercept. If I can find just those 2 points, would that technically be enough to plot the graph of the line? Yeah, because how many points do you really need to draw a line? 2. If I have 2 points, I can draw that line. So if I can find the 2 intercepts, I might be able to find the answer or the graph really, really fast and easy. And the way you do this is actually really simple. If I said, what do all the points on the x-axis have in common? So if I said this, tell me what the coordinates of that point right there could be. 1, 0. What about this point over here? 7, 0. What about this point over here? -4, 0. What does every single point on that line have in common? But what do you mean by the 0? The y is equal to 0, right? So what we can do really easily, if I want to find the x-intercept, all I have to do is rewrite the equation, but instead of the y, what do you think we're just going to plug in? You plug in a 0 for the y. So basically 3 times 0 goes away, and I get right away to 2x equals 12, so x is going to equal 6. I know just that easy that this line is going to go through 1, 2, 3, 4, 5, 6. That point right there. I know that. I know my x-intercept really fast is 6. Because all we do is we plug in a y for 0, that goes away, we divide by 2, x equals 6. What do all the points on the y-axis have in common? What are the coordinates of this possibly? 0, 3. How about up here? 0, 7. How about down here? 0, negative. What does every single point on the y-axis have in common? But where? The x will equal 0. Instead of the y equaling 0, the x will equal 0. So if I want to find the y-intercept, all I have to do is, again, rewrite that equation, but replace the x this time with what? With 0. So that 2 times 0 goes away. I just get 3y equals 12. So y is going to equal 4. So I go 1, 2, 3, 4. I know that point right there. And all I have to now do is connect. Come on, go away. Shoo. The dots. I don't know why that wouldn't go away. Like, it really is that easy. Using the intercepts to graph a line, especially if it's in standard form. If you give any equation like negative 2x plus 5y is equal to negative 20. How do I find the x-intercept? To find the x-intercept, which one becomes 0? The y. To find the x-intercept, basically the y is going to become 0. So that goes away. I got negative 2x equals negative 20. So x is going to equal? What's x equal? It's negative 20 divided by negative 2. 10. And then, to find the y-intercept, instead of making the y equal to 0, now we just make the x equal to 0. So this negative 2 times 0, that goes away. I basically just have the 5y equals the negative 20. And what's y going to equal? Negative 4. So I know on my graph, the y-intercept, 1, 2, 3, 4, right there. The x-intercept out here at 10. The line, connect the dots. Like, it really, really is that simple. Now, what is one of the benefits of graphing this method? Fast. This is a super, super fast method, right? It's also, I would say, super easy, isn't it? It's super easy, especially if it's in standard form. What if it's not in standard form? What if it's like y equals 3x minus 5? Do you do it any different? Well, how would I find the x-intercept? What do I do to make the x-intercept? Make the y 0. So the y becomes a 0. Now I have to solve this. So I add the 5, 3x. So x is going to equal, 5/3. How do I find the y-intercept? I make the x 0. So y is going to equal 3 times 0 minus 5. Well, that's just 0 minus 5, which is y equals negative 5. What do you notice about this problem? One, was it a little harder to solve for the x and y intercepts? A little bit. What also is a downfall of this method? Sometimes you got ugly y-intercepts. They're not always, not all points, not all lines. If you graph on a piece of graph paper and I draw a line, are all of your lines that you draw going to hit the y-axis or the x-axis at nice points? No. Sometimes they are ugly points. So if it is an ugly point, okay, now we got to deal with decimals, and it's kind of hard to be precise at that point, right? It's really easy to be precise when it's nice points. Sometimes they are a little bit uglier. So it's not a, it does have its weaknesses. Throughout this chapter, I'm going to give you multiple ways of graphing lines. What's a discussion that we have to have on every single new method? So we talked about just plotting -2, -1, 0, 1, 2. Now we have x and y intercepts. Don't we have to kind of weigh the pros and cons of each one? So as we go, we kind of have to have that discussion of when to use this method, why do we use this method, what are the pros, what are some of the cons that we could run into, what are some problems we could run into that maybe one method is better than the other. Should you tie yourself and say, ooh, I like this method the best and I'm always going to use this method? Why not? Well, do you think I have a favorite method that I use most of the time? Yeah. Do I think you should have your favorite method that you use most of the time? Absolutely. But every method is going to have some problems once in a while, where a different method might be better in this case. And if you know which method is better for which problem, it's kind of like, a carpenter having multiple tools. I can have a circular saw to cut stuff, but should I use that circular saw for every single cut that I have to make? Why not? Well, sometimes you need more fine-tuned, like super fancy cuts. Sometimes, it's too big and it doesn't fit in the area that you got to make a cut. Whatever. There's lots of, that's why they have multiple tools, right? That's why carpenters have 12 different types of saws. They all do the same basic thing. They all cut stuff. But they cut stuff in different ways for different applications, right? Same idea with these different methods with linear equations. You're going to have your favorite tool. You're going to go to that most of the time. But you also need to understand its strengths and weaknesses. What are the weaknesses of the plotting the -2, the -1, the 0, 1, 2s? Time. Like it's just tedious. It really is. What's a weakness of this method, the x and y intercepts? Could be ugly numbers. It also, I would say, if it's not in standard form, if it's in this form or some other form, if it's not looking like this, if it's in standard form, I'd say this method is really easy, right? Another problem of this, how many points are you really plotting? 2. When we did the other method, we plotted 5 points. If you drew the lines and you plotted the points, and you got a point here, a point here, a point here, a point here, and a point here, what would you easily recognize? I screwed up. I made a silly mistake, right? I either miscounted or, oh yeah, that was, instead of -5, that was supposed to be positive. I just put that in the wrong spot. Okay, whatever mistake I made, I recognize I made a mistake. With this method, how many points are you really plotting? 2. If you were to do something like this, let's say I gave you the equation 2x plus 4y equals 8. Super easy. X-intercept, I turn the y into 0. So 2x plus 0 equals 8. So 2x, see, put my hand on there and it does that. 2x equals 8, so x equals 4, right? And then my y-intercept, I make the 0 for the x. So 0 plus 4y equals 8. So y equals 4. So I go graph. and I go 1, 2, 3, 4, x-intercept 1, 2, 3, 4, and I move on to the next problem, right? Everything perfect? Did I do everything correctly? No, I did something wrong. What did I do wrong? What? Yeah, 8 divided by 4 is not 4. I made a mistake. This method, another problem with this method is because you're only graphing 2 points, there isn't that extra point to kind of double check your work. You may want to plot one more point just to be safe, especially if it's basically what we're doing here is the same method as before. We're still plotting points. The only difference is we're only plotting 2. We're going to put a 0 in for x and see what we get. We're going to put a 0 in for y and see what we get. Why zeros? Because 0 is easy. That's why they're easy, right? That's really what we're doing. But the problem with only plotting 2 points is not a whole lot of data to go on, right? This stuff seem pretty easy, though? All right, everybody take a look at page 306. Super big homework assignment. I know, I'm mean. Page 306. Sorry. It won't take you very long. This stuff's super easy.